is we have 20 minutes to have a discussion and more in-depth questions with the authors, because before later on you can proceed and talk to the authors in front of the poster. So I know that during some of the talks we had some questions that we did not have time to take. So are there any questions that you would still like to ask the authors from you were not able to? Okay, here, a gentleman in a red shirt.
Hi, thank you all for the great presentation. I know that a lot of you are focused on the accuracy of your method of motion tracking. I was wondering if you can argument a little bit on the sampling rate that having these composite pipelines for motion tracking actually achieves from the smart glasses with the microphone to the capacitive sensing, just out of curiosity. Okay,
let's start maybe from the other side and go.
Sampling rate was the same with the video, so 30, 60 hertz.
You mean, so you were asking the frame rate?
Yeah, because having the deep learning pipeline to kind of process all the data to estimate the portion, I think introduce some latency. I just want to, to know.
So my EMF tracking system is 60 hertz.
Okay.
So my post-sonic system is 25 hertz, and we can achieve more than 30 hertz by quantizing the model. That means that we are not using the floating point precision. Instead of that, we're using integer 8, and using that we can achieve till 80 hertz for post-sonic.
Yeah. Okay.
Yeah. Okay. So we used a computer vision model, and our video was 30 hertz, 30 frames per second, and we did a separate study. I mentioned the Wizard of Oz study, and we did that without running the system. So we wanted to calculate the latency. How was that difference? So we found that with the computer vision model, it was a second more for making the detecting his gesture. That was the average time for detecting with the model. And without the model, it was 1 second less.
Right. Thank you.
I get 66 frame rate per gesture, and one gesture is about 24 seconds.
Okay.
Yeah, the frame rate does matters a lot in our head tracking system, and our current sensing system is about 14 frames per second, and our sampling rate is 256, and it depends on how we configure the radar sensor. Yeah, how many resolutions we want to achieve. Yeah.
Thank you. It's way higher than I expected for all the system. I was expecting the deep learning to have had much more latency. Thank you.
Okay, next question. Gregory.
So I apologize. I stepped out for a little bit to see 2 talks over there, so I missed 2 talks, but I'm pretty sure this applies to all of you. I've been on this kick over the last 5-10 years about we need to take more seriously the sustainability of our solutions. But sustainability has many, many dimensions, so I'm going to focus on just one. How could you do any of your systems in a way that is self-sustainable with respect to the power needs for operation alone? Is it out of the realm of possibility for any of your solutions? Or could you imagine a way where you could either harvest or do things that wouldn't require recharging or changing a battery? Is that possible?
So who of you thinks that her or his system could actually do that? Operate without external source of energy?
I think I do some work on energy harvesting, but I have to admit that our current radar system is very power hungry, but I can imagine that we can harvest energy from our hand motion and maybe the body motion. We can harvest some kinematic energy from human beings themselves.
What about the ultrasonic system? We were praising it as being so extremely power efficient. So is it something you could actually feed from I don't know, if you really do serious head banging for your glasses, maybe?
So regarding the sensor, I don't have the data, but I believe we can harvest energy, and that can be enough for capturing the data, or I mean the echo. But I think there is one more dimension here, that is saving the data or transmitting the data to somewhere else. For that, I think energy harvesting is not enough for my system right now. Maybe.
Okay, Bo?
So that's actually gave me an idea maybe for our next paper, because there are wearable solar panels, and the solar panels are also supposed to be conductive, and we can see whether the capacitive patches can be combined together with solar panel, because with capacitive sensing, what we have is like a surface area, and actually the bigger the area, the better the sensitivity it is. And we can also look into triboelectric fibers to harvest the energy when you move, and especially when you have something not on a node but a full body, then you have a lot of area, a lot of joints to harvest those kinematic energies.
Okay, thank you. Other questions? Yep.
My question related to the pose estimation work, the one that use acoustic and some other modality for upper movements. So if you look at your system is actually underdetermined, because you only instrument the sensors at the fingertip, or you just use a reflection from the acoustic waves. So that kind of leads to my conjecture that the model that trained may not work well for events like rare actions or people who are not like typical in the MS data set or whatever data set, public data sets you utilize. I wonder whether you guys have any comments on that. I'm sorry? I mean, if you just know the fingertip, right? So the inverse kinematic is undetermined, right? There are possibly different joint positions. So I think largely the prior that you obtain from the public data set actually largely influence the outcome. But if you take a rare motion, rare events, or people who have, kind of uncommon type of anatomy, I would conjecture that the system would not work very well. I wonder whether you agree with that, or any further comments along those lines.
So that's directed at any specific person, or at
I think the ones that are more
the body tracking, right?
With underdetermined setup. I think the capacity sensor maybe is denser, so I would think probably less problematic, but I'm still concerned that, as you also mentioned, that for different people the results are quite different, right?
Yeah, maybe you should. Yeah, you should start answering, because I think it's mostly at the two of you there.
Sure. So yeah, I think that your point is very valid, and so for, as I mentioned, my model is trained on a large scale of data set of human pose, and which, of course, doesn't contain some rare motions. And we have observed, like, for example, in our case, there are tennis motion or golf motions, and those motions the model didn't. The model showed the worse results for that. And I think one solution to this is sort of combining the inverse kinematic solution, which I currently use, and also forward kinematics model, so that we can use the sensor data directly to estimate the other joint position, so that we don't fully rely on the data-driven model, but we also can combine a hybrid approach to use the sensor data as well.
Maybe I was thinking maybe we could maybe increase the MS data set, for example, to add those uncommon through diffusion or style transfer, or for example, the same motion and you insert different body type, or even with the same body type, you can induce more noise through diffusion methods. So to expand the data set, to expand the coverage.
I was also wondering the same thing about especially this acoustic system, right? It sort of seems to me like you have your sensor right here on the head, right? And yes, you're looking at the stuff. So you capture pretty well are the arm motions, right?
Right.
But it seems to be like all. I mean, if you tilt your head, or what happens, or do you capture something like this as well? So it wasn't quite clear what
Yes, I think in our lab study, we did not capture the head movement, but for semi in the wild study, we did capture the head movement. And I think it was one of the factors that degraded the performance in the wild study. But I believe that it can be solved to some extent if we use an IMU in conjunction with the acoustic sensing so that we can have the head rotation information that can supplement the acoustic sensing.
And other thing that I have in my mind, when I was listening to the last talk about this head monitoring for watches, it's like a really nice application, right? Using the head to see the watch. I was thinking, yeah, this radar is cool, but actually if you put your acoustic sensor in the watch, wouldn't it actually be a really good way of tracking these head motions as well?
Yes, I agree. Thank you for the idea.
Because it seems like a low power thing, really easy thing to put into a watch, yes. Right? Okay. Okay, any more questions or discussion points? Okay, so one thing I would like to hear is, especially looking at those of you who are doing like really body tracking, right, the 3 ones. If every one of you could say in a few sentences, what do you think are the best and the worst points of your system compared to the others, right? It's really interesting if you say, you know, use my system always because it's always the very best and forget the others. Or is it more like, you know, my system is good there and bad there and those are the stronger weak points. So really interesting to you know, after you have heard the others, to reflect of what you do, how it relates to it, or maybe you know where you could use the other system and fuse it.
Sure. So okay, so beta point first. I think my EMF tracking system is, since the EMF tracking is pretty accurate, the output body pose is pretty plausible and accurate, and also it's very fast and it's a robust occlusion. But yeah, those are also shared by other work still. I would say like for the worst point is form factor. Still like my system is for AR scenarios, so I use 1 glasses and 2 wrist-worn sensors. But in terms of like form factors, their works have more natural and already like installed. We can install the systems like in everyday life. So.
Okay, yeah. Bo? Or sorry if you.
All right. So for my system, I feel that the best part is the user agnostic sensing, so that like as we are tracking the trajectory, not the shape, so it's easier to deploy for new user without the training data. And if you ask me about the worst part, probably I can think of that a lot of people may start using our system. And if every one of them, like everyone is wearing a glass and transmitting the ultrasonic, and it can interfere each other's sensing or like the inference. That may be an issue that could be solved in the future, like large-scale deployment that I believe is an issue right now.
Okay, Bo?
So I think for us, the best is it's like a design-centric method. You can put this different patterns on it, and the designers don't need to worry about where exactly to place the sensor. We just have a different pattern design and gather some data and train a regression model. But also that's the worst part is you need to train a model with, you need to gather some data to train this model with every new design. And because it's we use a black box approach. So you need to have some data of people moving, dancing, and then train the model.
So maybe from me, a question there, please.
Thank you very much for your discussion and the presentation, which is amazing. So, well, you know, I haven't done anything on pose estimation, but, you know, I mean, to me, the barrier is a bit too high. You know, that seemed to me those sensors are designed, you know, specially designed. You know, if I want to jump into this field, how can I get access to those sensors? You know, I read 3D pose estimation uses vision. I can understand. Then I can easily reproduce or use Wi-Fi, you know, CSI channel, you know, they just like easy to reproduce. But with those sensors, you know, like I read your paper, well, hardware, how can I get that? You know, I mean, to other people in the community, can you give us some suggestions?
Yeah, it's always the question when you look at hardware-based papers, right? So I don't know, any of the people here especially have something like, you know, or your designs on GitHub or something like this? Or is it like go study electrical engineering and you can build it?
For reproducibility, I think our work has a GitHub and it's open. But maybe a deeper question is how you want to use more different modalities. Maybe the story is like for Imali's work is we saw this movement that produces repeatable signal, and then we say, okay, let's try to use this to trace back the pose. So it's more like observing an artifact in the real world that your motion causes the signal to change in a certain way that is repeatable. I think it's the same for all of these. It's the same for gesture recognition also.
Yeah, I mean, how can I get your hardware? For example, you've got
get the hardware.
I mean, that's the thing.
You need to have someone study electrical hardware.
Technology, yeah.
Yeah, I think the, yeah.
That's a good one.
So if you look at my paper, I have provided the link to the vendor for each of the components I used. Okay. And probably I can release the PCB design so that you can go to the vendor, use the same equipment, use the same PCB design, make it the hardware ready for you.
So I think actually it's a good point. It's something we should take up to the IMUD steering committee, and you know, like just like you now require people who do machine learning to provide you maybe code reproducibility, that for hardware papers you could acquire people to provide on GitHub at least the schematics or you know the Gerber file for making it. Having said that, and work with hardware, it's nice to have that. But unless you really know what you're doing, it will not be of any use to you. But still, it would be nice to have these things there. Do we have any more questions? Somewhere in the back there, yeah? Or Michael? Yeah, you first.
Just a short comment.
You ran faster,
on that, on the reproducibility of hardware. I mean, there is hardware and hardware. So there are special sensors like capacitive sensing, which is difficult to reproduce. But for many of the hardware that I see today, I would say if you have the PCB on GitHub, which is shell PCB compatible, you get the hardware completely ready, produced on your desk for almost most of the components or even all of the components. I don't know how it is with yours, but for many of the things that we have seen. So it is not like 10 years ago where it is impossible. Even with no clue what you're doing in terms of electrical engineering, you can decently make your way.
Yeah, I agree. It's something we should take up in the community, that also for hardware papers, we will look at this reproducibility, usability, but it's really important to remember there are things you can easily, you know, you get a PCB, it works, and there are things that it doesn't, but still will be an improvement. I think somebody was there, the lady with the mask, you want to ask a question? Okay, please. Sorry.
We had this experience. We use someone else's PCB, but the parts cannot be sourced anymore. Some of them just not available. So it's not a cure-all solution.
But it helps. It improves the reproducibility. Okay.
It's an important step.
Now you can pose your question finally.
My question is sort of going back to the lack of the rare pose related question. So I see like all three of your works have the sensors on both sides, left and right, and then sort of sensing the different size of the body. How does it work when user makes a cross arm gesture where the right arm goes to the left side of the body and the left arm goes to the right side of the body? Especially the acoustic one, I was curious how it works.
I evaluated that. So for that, we included a few gestures like cross arms and other things, and the performance was consistent. So we did not observe any sort of degradation when you do like this or like this. It was consistent for acoustic sensing.
Okay.
Yes, mine as well.
Oh, sorry, no, please. Sorry.
Okay, so yeah, mine as well. It's robust against the kind of swinging motions. So like if the arms are switching, we can distinguish the signals like from which sensor the signal is coming. So based on that, we can apply inverse kinematics and to get plausible body pose.
So we have those cross-arm movement in the training data, and those are also like really nicely recognized.
Okay, so I think it's one last question because then we need to, the rest we can do in poster sessions and discussions. So,
yeah, I just had a quick question. Hi, Vimal. So I saw a lot of the papers use MediaPipe or some other like vision-based system for ground truth tracking, which was like not very accurate, and that seemed like a limitation for a lot of the yeah. So I was just wondering, like, why not some other system? Like, is it just expense or something else, or yeah?
So the benchmark paper, we actually proved that they are as accurate as the reflective marker mocap. Because reflective marker mocap, it tracks the surface marker very correctly, but the internal joint is not really that correct, even for the reflective marker systems. So, but this is not like, we open the code as a Blender plugin, and we can render the image and then put it through different, so the point is to benchmark different methods. So it's nice to use this as a benchmark as other methods also.
Yeah, I was just wondering, like, in general, because I see that a lot of papers, like, in the community use, like, some vision-based system for ground truth tracking. Like, I think even in post-sonic, for example. And it's really good for, like XY locations, like 2D tracking. But depth especially, like, you can see the body is, like, tilted like this, which is just unfortunate. Like, I was just wondering maybe if you could use a multi-view setup or something like that. Yeah.
I think if I used mocap systems like OptiTrack, it would have been more accurate. I agree with Vimal on that part. But I think one more thing to be noted, that we tried to do the study in the wild setting. Suppose we tried to collect the data in a restaurant. So how can I have the mocap system there? That's why probably we went for the MediaPipe that is like off the shelf. We can use it anywhere, just you have a camera. That can be one reason, but I definitely agree that the ground truth itself has some margin of error.
Cool, thanks.
Okay, thank you. So before you all leave, first of all, thanks everyone for your answers and discussion. And please don't leave yet. I'll be beaten up. You can leave, but people can leave the room, so that's okay. I was asked to present something about the upcoming opening reception, and while my slides are not showing, still I like to take. So we have 5:30 to 6 p.m. We have ISWC Design Exhibition in the Cobra Room. Then 6 p.m. we have demos in the hallways in the second floor. Then we have posters and late-breaking work at 6:30, and then at 7 we have ISWC Gadget Show. Very important. All those wonderful gadgets that people have, we would like to show them off. And also we have a Best Poster Award, Best Demo Award, Best People's Choice Award for Best Poster, and People's Choice Award for the Best Demo. And for those choice awards, you can get yourself a sheet that you need to have signed by the authors that you can use to vote. So please attend those events and enjoy them. And if you have a gadget, anything you presented, come to the Gadget Show and show it. Thank you.